There are planets in our universe that defy everything you thought you knew about worlds. Planets where it rains molten glass sideways at 4,300 miles per hour. Ocean worlds so deep that if you dove to the bottom, you'd be crushed by pressure 1,000,000 times stronger than Earth's deepest ocean trench. And massive gas giants so large they're almost stars. Worlds where the laws of physics are pushed to their absolute breaking point. Today, we're going on a journey to explore the most extreme planets in the universe, from the smallest rocks barely bigger than our moon to the absolute monsters that blur the line between planet and star. We'll visit lava worlds with surfaces hotter than some stars, rogue planets wandering the galaxy alone in eternal darkness, and worlds orbiting dead stars where the radiation would kill you instantly. But here's what's truly mind-blowing. We've only discovered about 5,000 exoplanets so far. There are likely trillions of planets out there in the universe, and every single one we find seems to break the rules we thought we understood. So buckle up, because what we're about to explore will change how you think about planets forever. Let's start our journey with the tiniest worlds in the cosmos. But before that, please subscribe to our channel. That would really help. Before we explore the giants, let's appreciate just how small planets can get. In our own solar system, we have Mercury and Mars. Mercury is just 5% of Earth's mass, while Mars clocks in at about 10%. If you stood on either of these worlds, you'd experience only about 40% of Earth's gravity. You could jump nearly 3 times higher than you can on Earth, but these aren't even close to being the smallest planets we've found. That honor goes to Kepler 37b, the tiniest confirmed exoplanet in our catalog. This little world is actually smaller than Mercury. You couldn't even fit the entire continent of Asia on its surface. Imagine a planet where you could see the curve of the horizon just a few miles away, where walking in a straight line for a few weeks would bring you right back to where you started. But here's the fascinating question. What's the absolute smallest a planet can be? We ran simulations to find out. Using the definition that a planet must be in a clear orbit around a star and achieve hydrostatic equilibrium, meaning it's roughly spherical with no massive lumps, we found the theoretical minimum. This hypothetical planet would be less than 5% of Earth's radius. On a world this small, a 150-pound person would weigh less than 4 pounds. You could literally jump 160 feet high with ease. Walking a complete loop around this planet would take only 47 days, and its total surface area would be roughly equal to France and Spain combined. The surface gravity would be so weak that throwing a baseball hard enough could potentially send it into orbit. The escape velocity, the speed needed to leave the planet entirely, would be slower than a car on a highway. This is as small as planets can theoretically get while still being considered planets. Now let's go bigger. Super-Earths are one of the most intriguing categories of exoplanets, and ironically, they're the most common type of planet in the Milky Way galaxy. Yet we don't have a single one in our solar system. We still don't really understand why. Meet LHS-1140b, one of the most fascinating super-Earths we've discovered. This rocky world is almost 7 times more massive than Earth, yet only about 70% larger in radius. That means it's incredibly dense. A 150-pound person would weigh around 375 pounds there. Moving around would be possible, but you'd definitely struggle. Every step would feel like you're carrying 2 other full-grown people on your back. But here's what makes LHS-1140b special. It sits right in its star's habitable zone. The surface could potentially have liquid water. With nearly 3 times more land area than Earth, imagine how massive the continents could be. Entire civilizations could rise and fall on landmasses that dwarf anything we have here. Then there's Toy 849b, an even stranger world. Looking at its size, you might guess it's maybe 4 or 5 times Earth's mass. But here's the shocking part. It actually weighs 40 Earth masses. It's nearly the size of Neptune, but twice as massive. How is that possible? Scientists believe Toy 849b might be the exposed core of a gas giant. When a planet orbits too close to its star, the intense radiation can blow away all the outer gas layers over millions of years, leaving behind just the dense, rocky, and metallic core. What we're seeing might be the skeletal remains of what was once a Jupiter-sized giant. Living on a super-Earth would be brutal for humans. Your bones would strain under the constant pressure. Your heart would work overtime, pumping blood against the increased gravity. But if life had evolved there, it would be radically different from Earth life, perhaps with stronger skeletal structures, more powerful muscles, or entirely different body plans we can't even imagine. Now we enter the realm of truly alien worlds, the hot Jupiters. These are gas giants that orbit so close to their stars that their atmospheres are literally being torn apart, and the conditions there are beyond anything you can imagine. First up is WASP-12b, a planet that's being devoured by its own star. This Jupiter-sized world orbits so close to its star that it completes one orbit every single Earth day. The star's gravity is so intense that it's pulling the planet into an egg shape, and the planet's atmosphere is streaming off into space like a comet's tail. Scientists estimate that WASP-12b will be completely consumed by its star in about 10 million years, a blink of an eye in cosmic terms. The surface temperature? Over 4,500 degrees Fahrenheit. That's hot enough to vaporize iron. The planet is so hot that it actually absorbs nearly all light that hits it, making it one of the darkest planets ever discovered. If you could somehow stand on this world, which you absolutely couldn't, you'd be instantly vaporized, and then that vapor would be stripped away into space. But WASP-12b isn't even the most extreme hot Jupiter. That distinction belongs to HD 189733b, a planet where it rains glass, sideways. At 4,300 miles per hour, this beautiful blue world, yes, it actually looks blue from space, has winds that are 7 times faster than the speed of sound. The intense heat breaks down silicate particles in the atmosphere, which then condense into tiny glass droplets. These glass particles whip around the planet in supersonic winds, creating horizontal rain that would shred anything in its path. The temperature difference between the day and night sides of HD 189733b is extreme, about 500 degrees Fahrenheit. This creates these planet-wide wind patterns that transport heat in a never-ending storm. The entire planet is essentially one giant, eternal hurricane made of molten glass. Then there's Kelt 9b, the hottest planet we've ever discovered. With a surface temperature of over 7,800 degrees Fahrenheit, this planet is hotter than some stars. It's so hot that molecules can't even exist on the day side. Everything is broken down into individual atoms. Hydrogen, usually the lightest gas, forms an extended atmosphere that's literally evaporating into space. This planet is destroying itself in real time, losing thousands of tons of material every second. The star that KELT-9b orbits is so hot and bright that the planet is essentially being roasted alive. Scientists estimate that the planet has already lost significant mass since its formation. Eventually, it might be stripped down to just a rocky core, like TOI 849b, we discussed earlier. If you thought hot Jupiters were extreme, wait until you hear about lava worlds, planets where the entire surface is a churning ocean of molten rock. Let's start with 55 Cancri e, nicknamed the Diamond Planet. This super-Earth orbits so close to its star that it completes an orbit in just 18 hours. The surface temperature reaches 4,400 degrees Fahrenheit. But here's where it gets interesting. Scientists believe that due to the intense pressure and heat, much of the carbon in this planet's interior has been compressed into diamond. Imagine a world where beneath the surface of molten rock lies a layer of diamond potentially miles thick. The planet's entire mantle could be made of the most valuable substance on Earth. Of course, you'd never be able to mine it. The surface is a literal hellscape where rock flows like water, and the atmosphere, if you can call it that, is made of vaporized rock. But 55 Cancri e might not even be the strangest lava world. That honor could go to K2141b, a planet so extreme that its entire weather system consists of rock. Yes, you read that correctly. Rock weather. On K2141b, the dayside is so hot, over 5,400 degrees Fahrenheit, that rock vaporizes into the atmosphere. This rock vapor then travels on supersonic winds to the night side, where it's cold enough for the rock to condense and fall as rain. Liquid, rock, rain. This molten rock then flows across the surface back to the day side, where it evaporates again, completing the cycle. It's like Earth's water cycle, but with rock instead of water. The planet has rock clouds, rock precipitation, and oceans of lava that circulate the entire planet. The temperature difference between day and night is over 4,500 degrees Fahrenheit, creating the most violent weather patterns imaginable. Then there's Coro T7b, one of the first rocky exoplanets ever discovered. This planet orbits its star so close that one side permanently faces the star, it's tidally locked, just like our moon is to Earth. The dayside temperature reaches 4,500 degrees Fahrenheit, while the night side drops to negative 350 degrees Fahrenheit. Scientists believe the dayside has oceans of molten lava, while the night side might be covered in frozen rock. Between these two extremes is a twilight zone, a narrow band where temperatures might be just right for solid rock to exist on the surface. If you could stand anywhere on this planet and survive, it would be in this thin strip of twilight, watching the eternal sunset while lava oceans bubble on one horizon and frozen wastelands stretch out on the other. Now let's cool things down considerably and visit the ice giants, worlds made mostly of water, methane, and ammonia ices, crushed under enormous pressure. In our solar system, Neptune is our prime example of an ice giant. It's about 4 times wider than Earth, but 17 times more massive. The pressure inside Neptune is so intense that scientists believe it might actually rain diamonds in the planet's interior. Carbon atoms from methane get squeezed so hard that they crystallize into diamond, which then sink toward the planet's core. Imagine diamond rain falling through an ocean of liquid methane. But the most intriguing ice giant we've found is K2-18b, and it could change everything we know about habitable worlds. This planet is nearly 3 times wider than Earth, but has a surprisingly similar surface gravity. It orbits within its star's habitable zone, the region where temperatures are just right for liquid water to exist. Recently, the James Webb Space Telescope, the most powerful space observatory humanity has ever built, studied K2-18b's atmosphere. What it found shocked the scientific community. The atmosphere is rich in methane and carbon dioxide, and there's possible evidence of a molecule called dimethyl sulfide, a compound that on Earth is only produced by life, though this detection is still being debated and requires confirmation. Scientists now believe K2-18b could be a Hycean world, a type of planet with a thick hydrogen atmosphere over a global ocean. Picture this, an entire planet covered in water, with no land anywhere. The ocean could be hundreds of miles deep, and the atmospheric pressure at the surface would be enormous, far greater than anything on Earth. If you somehow visited K2-18b, you wouldn't be able to stand on any solid surface, because there isn't one. You'd need to build floating structures, or perhaps cities, suspended in the upper atmosphere where pressure is more manageable. The ocean below would be an alien world of its own, with pressures so intense that water takes on exotic properties we can barely understand. The potential discovery of biosignatures on K2-18b has made it one of the most exciting targets for future study. Could there be life in those alien oceans? What would life look like on a world with no land, no seasons, and eternal cloud cover? We don't know yet, but K2-18b has become a top priority for the search for extraterrestrial life. Speaking of ocean planets, let's dive deeper into water worlds, planets where water dominates everything. Toei 1452b is perhaps the most promising water world we've discovered. Located about 100 light-years away, this planet is about 70% larger than Earth and sits right in its star's habitable zone. Based on its density, scientists estimate that up to 30% of this planet's mass could be water. To put that in perspective, water makes up less than 0.1% of Earth's mass. Imagine oceans that are hundreds or even thousands of miles deep. At those depths, the pressure would be so intense that water would transform into exotic states of matter. Near the bottom, you'd find supersonic ice, water that's simultaneously solid and liquid, where oxygen atoms are locked in a crystalline structure while hydrogen atoms flow freely like a liquid. This bizarre state of matter can only exist under the extreme pressures found deep inside massive water worlds. The surface of TOI 1452b might be relatively temperate, with liquid water oceans under a thick atmosphere. But as you dive deeper, you'd pass through layers of increasingly exotic water. Eventually, you'd reach the rocky core, buried under an ocean so deep that the bottom has never seen light and never will. Another fascinating water world is GJ1214b, one of the first potentially water-rich exoplanets discovered. This planet is about 2.6 times wider than Earth, and observations suggest it has a thick atmosphere rich in water vapor. Some scientists believe the entire planet might be covered in a global ocean with no land masses whatsoever. But here's where water worlds get really strange. If the ocean is deep enough and the planet massive enough, the bottom of the ocean might not be liquid at all. Under the crushing pressure, water would freeze into a type of ice called Ice 7, a form of ice that exists at temperatures well above water's normal freezing point. So you could have a planet with boiling hot oceans on top and ice at the bottom, not because it's cold, but because the pressure is so intense. Could life exist on water worlds? It's possible, but it would face unique challenges. With no land and no obvious source of the minerals life needs, any life would have to be entirely aquatic. There would be no fire, no technology as we know it, no way to observe the universe beyond the clouds. Any civilization that evolved there would have a completely different understanding of the universe than we do. Some scientists speculate that life on water worlds might cluster around hydrothermal vents on the ocean floor, much like the bizarre ecosystems we find in Earth's deep oceans. These vents could provide the energy and nutrients needed for life, creating pockets of biology in otherwise barren seas. Now we reach the gas giants, the juggernauts of the planetary world. In our solar system, Jupiter and Saturn are our local examples, and they're already impressive enough. Jupiter is the undisputed king of our solar system. You could fit 1,300 Earths inside Jupiter's volume. Despite appearing similar in size to Saturn, Jupiter is actually 3 times more massive. In fact, if you combined all the other planets in our solar system, Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune, Jupiter would still outweigh them all combined. Jupiter's Great Red Spot, a storm that's been raging for at least 400 years, is bigger than Earth. The winds in that storm reach speeds of 250 miles per hour. The planet's magnetic field is 20,000 times stronger than Earth's, and it's surrounded by intense radiation belts that would kill an unprotected human in seconds. Saturn, while less massive, is arguably more beautiful with its spectacular ring system. Those rings stretch over 175,000 miles from end to end, but are only about 30 feet thick in most places. If you could somehow stand on Saturn's cloud tops, which you couldn't because it's all gas, you'd weigh about the same as you do on Earth, despite Saturn being 95 times more massive. That's because Saturn is the least dense planet in our solar system. It would actually float in water if you had an ocean big enough. But as impressive as Jupiter and Saturn are, they're nothing compared to what's out there in the wider universe. Now we enter the realm of the true giants, the super Jupiters, planets so massive they push the very limits of what we can call a planet. Rox 42 BB has one of the strangest names I know, but it's also one of the largest planets ever detected. This monster is about 2.5 times wider than Jupiter and weighs nearly 9 times as much. You could line up 50 Earths along this planet's width. But here's the thing about super Jupiters. They can't get much bigger than this. Once a planet grows beyond a certain mass, its own gravity compresses it into a denser object rather than letting it expand further. It's counterintuitive, but add more mass to a super Jupiter, and it actually gets smaller, not larger. The more you squeeze, the denser it becomes. Rox 42. BB is still glowing hot from its formation, over 2,900 degrees Fahrenheit. This heat causes it to puff up slightly, which is why it's able to be as large as it is. As it cools over millions of years, it will actually shrink, becoming denser, even though it's not losing mass. Then there's a planet with such a terrible name that I won't even try to pronounce it. What makes this super Jupiter special is its age, only about 200 million years old, and its magnetic field, which is 4 million times stronger than Earth's. This creates massive planet-wide auroras that dwarf anything we see on Earth or even Jupiter. But here's what's really fascinating. This planet doesn't orbit a star. It's a rogue planet, wandering the galaxy all alone in eternal darkness, searching for a companion it will likely never find. Despite being similar in size to Jupiter, it weighs 13 times more. A 150-pound person would weigh around 3,300 pounds there. You'd be instantly crushed flat by your own weight. Rogue planets like this are thought to be incredibly common in the universe. For every star in the galaxy, there might be one or more rogue planets drifting through the void. They're incredibly difficult to detect because they don't emit much light, and don't orbit anything that would make them easier to spot. We've only found a handful, but there could be billions in our galaxy alone, invisible wanderers in the cosmic dark. Let's explore rogue planets in more detail, because these are some of the most mysterious and haunting objects in the universe. Rogue planets are worlds that don't orbit any star. They either formed independently from collapsing gas clouds, or more commonly, they were ejected from their original solar systems through gravitational interactions. Imagine a young solar system where planets are still finding their stable orbits. A close encounter between two large planets could result in one being flung out of the system entirely, doomed to wander the galaxy forever. One of the first rogue planets discovered was OJ 318.5-22, located about 80 light-years away. This Jupiter-sized world has a reddish color, and despite having no star to warm it, still glows faintly from the heat of its formation. It's only about 12 million years old, a baby in cosmic terms. On a rogue planet, there would be no day, no night, no seasons, just eternal darkness and cold. Without a star, surface temperatures would plummet to just a few dozen degrees above absolute zero. Any atmosphere would freeze and fall to the surface as snow. The only heat would come from the planet's interior, residual warmth from its formation, or heat from radioactive decay in its core. But here's a fascinating possibility. Even without a star, a rogue planet could potentially harbor life. If the planet is large enough and has a thick enough atmosphere, the internal heat could maintain liquid water beneath a surface layer of ice. This is exactly the situation we have with Jupiter's moon Europa, which has a global ocean beneath its icy crust, warmed by tidal heating and radioactive decay. A massive rogue planet could have the same setup, just scaled up. Life could exist in an ocean heated from below, completely isolated from the rest of the universe, never knowing that stars even exist. To any intelligence that evolved there, the universe would seem to be nothing but darkness, with no way to discover the greater cosmos beyond their frozen shell. Scientists estimate there could be trillions of rogue planets in our galaxy alone, vastly outnumbering the planets that orbit stars. They're everywhere, passing through the space between stars in complete silence. One might even pass through our solar system someday, a cosmic visitor from the void. The closest rogue planet to us is probably within a few light years, closer than the nearest star system, but finding them is incredibly difficult because they're so dark and so cold. Future infrared telescopes might reveal that rogue planets are the most common type of planet in the universe, an entire invisible population of worlds we're only just beginning to discover. If rogue planets are haunting, pulsar planets are downright terrifying. These are worlds that orbit the dead remnants of stars, neutron stars that pulse with deadly radiation. The first confirmed exoplanets ever discovered weren't around a normal star at all. They were around PSRB 1257 plus 12, a pulsar, a rapidly spinning neutron star that emits beams of radiation. 3 planets orbit this dead star, bombarded constantly by intense radiation that would sterilize any surface. How did these planets get there? That's the mystery. When a massive star goes supernova, it should destroy any planets that were orbiting it. So either these planets somehow survived the supernova, which seems nearly impossible, or they formed afterward from the debris of the explosion. That would make them second-generation planets, born from the ashes of their dead star. The radiation environment around a pulsar is unlike anything else in the universe. The pulsar spins incredibly fast. This one completes a full rotation every 6.2 milliseconds, and with each rotation, it sends out beams of X-rays and gamma rays. If you were standing on one of these planets during a pulse, you'd receive a lethal dose of radiation in a fraction of a second. The planets themselves are probably dead, airless rocks. Any atmosphere would have been stripped away by the radiation long ago. The surface would be constantly bombarded by high-energy particles, making it one of the most hostile environments imaginable. But here's what's truly bizarre. Despite the hellish environment, these planets have some of the most stable orbits we've ever measured. Because the pulsar spins so regularly, more precise than even the best atomic clocks, scientists can measure the planet's orbits with incredible accuracy. That's how they were discovered, by detecting tiny variations in the pulsar's timing, caused by the planet's gravitational pull. Some scientists have speculated about what it would look like from the surface of a pulsar planet. The sky would be dark with no sun, but every few milliseconds, the entire landscape would flash with the pulsar's radiation beam. It would be like living under an incredibly fast strobe light, a world caught between instant flashes of deadly light and darkness. For something less deadly but equally fascinating, let's visit binary star systems, planets orbiting two suns, just like Tatooine from Star Wars. Kepler 16b was the first confirmed planet orbiting a binary star system. This Saturn-sized world orbits two stars simultaneously, experiencing the most complex sunrises and sunsets imaginable. Sometimes both suns rise at the same time. Sometimes they rise hours apart. The length of a day varies wildly depending on where the planet is in its orbit and where the two stars are relative to each other. But stability is a major challenge for binary star planets. The gravitational interactions between two stars create regions where orbits are unstable. A planet can only exist in certain zones, either very close to one star, far from the other, or in a wide orbit around both stars. Any planet in between would be pulled apart or ejected from the system. Kepler 47 is even more remarkable. This system has two stars and at least 3 planets orbiting them. One of those planets, Kepler 47c, orbits within the habitable zone. It's a gas giant, so you couldn't stand on it. But if it has moons, those moons could potentially support liquid water on their surfaces. Imagine standing on a moon orbiting a gas giant that orbits 2 stars. You'd see the giant planet taking up huge portions of your sky, its storms and clouds clearly visible, and above that, 2 suns would trace complex paths across the sky, creating double shadows and turning the most beautiful skies imaginable. The stability of these systems suggests that planets around binary stars might be more common than we thought. Perhaps half of all stars in our galaxy are in binary systems, which means a huge fraction of planets might experience the light of 2 suns. Finally, we arrive at the absolute limit of what can be called a planet, brown dwarfs, objects so massive they blur the line between planet and star. Typically, anything below 13 Jupiter masses is called a planet, while anything above 80 Jupiter masses is a star. That leaves a gap in between, the brown dwarf desert, occupied by objects that aren't quite either. Brown dwarfs are sometimes called failed stars, because they're not massive enough to sustain hydrogen fusion in their cores, though they can fuse deuterium for a brief period. But these definitions aren't hard limits. The truth is, we're still debating where the line should be drawn. Corot 3b is a perfect example of this ambiguity. It's about the same physical size as Jupiter, but 22 times more massive. Is it a giant planet or a brown dwarf? We honestly aren't sure. What makes classification difficult is that stars and brown dwarfs form differently than planets. Stars and brown dwarfs form when clouds of gas collapse due to gravity. Planets, on the other hand, form from the rocky debris and gas around newly formed stars. But Corot 3b's origin story is unclear, which makes it impossible to definitively classify. Here's what really blows my mind. Corot 3b is incredibly dense, more than twice as dense as lead, but it's still made entirely of gas with no solid surface. How is that possible? The answer lies in extreme pressure. Deep within objects, this massive hydrogen gets squeezed so hard that electrons are forced out of their orbits, forming metallic hydrogen, an exotic state of matter that behaves more like a liquid metal than a gas. This metallic hydrogen is far denser than any solid we're familiar with on Earth. At the very core of the largest brown dwarfs and smallest stars, pressures and temperatures reach levels we can barely comprehend. Matter exists in states that can't be recreated in any laboratory on Earth. It's a glimpse into physics at its most extreme. So what should we take away from all of this? We've traveled from the smallest theoretical planets you could balance on your hand to massive brown dwarfs that are almost stars. We've visited lava worlds where rock rains from the sky, ice giants with diamond rain, rogue planets wandering alone in eternal darkness, and worlds orbiting 2 suns or dead stars. And here's the thing. Every single one of these planets teaches us something about the universe. They show us that planets can exist in conditions we never imagined. They challenge our understanding of formation, stability, and even the definition of what a planet is. But perhaps the most important lesson is this. Planets and stars aren't as different as we once thought. A planet is really just an object that didn't gain enough mass to become a star. The line between them is blurry and arbitrary. In the end, they're all just different outcomes of the same process, gravity pulling matter together. We've only discovered about 5,000 exoplanets so far out of trillions that likely exist. Each new telescope, each new detection method reveals worlds that surprise us. The universe is far stranger and more diverse than we ever imagined. My question for you is, if you had to live on one of these planets, which one would you pick? Would you choose the challenge of a high-gravity super-Earth, the eternal twilight of a tidally locked world, the double sunsets of a binary star planet? Or would you brave the crushing oceans of a water world? Let me know down in the comments below.